So the work that I already showed on page 2 here is really what this next one is about. This is called the change of variable for indefinite integrals. The only thing we have to be careful about is when we start doing it with definite integrals. But let's look at this. It says with a formal change of variables, you completely rewrite the integral in terms of u and du, or another convenient variable. So you don't have to use u, but that's the convention. It says although this procedure can involve more written steps than the pattern recognition, it is useful for complicated integrands. The change of variable techniques uses Leibniz notation for the differential. That is, if u equals g of x, then du equals g prime of x dx. And the integral in theorem 5.31 takes the form. The integral of, well, that's the chain rule, right? Says equals the integral of f of u du, which equals the capital, the parent function f of u plus c. It talks about the previous simple power rule, where you add the power and you divide by the same number, and then it just starts looking at these individual problems right here. So it starts saying, like, notice that the derivative with respect to x of x squared plus 1 raised to the fourth, you would drop the power, so that'd be 4, keep the inside the same, so that's x squared plus 1, power minus 1 is a 3, and then you have to multiply it times the derivative of the inside. Well, the derivative of x squared plus 1 is 2x, right? And so then here what they did is divided both sides by 4. Okay, here's dividing both sides by 4. And what they're showing you here is that power rule. So the integral of this thing cubed would be this thing raised to the fourth over 4, right? But then you have to worry about the derivative of the inside. So all they're doing is engineering the problem backwards for you. Again, we've already done this substitution where we've substituted in u, we substituted in for dx, and we got what they wanted. So here were the steps that I was talking about on the previous page. This was what I called step 1, identify u. Step 2 was find the derivative of each side. What I called step 3 was solve for dx. Step 4 is where we substituted in for u and dx, and it says everything should cancel and your integral should now be in terms of u's and du's. Step 5 is what I said with integrate. Step 6 was what I said with back substitute. And then, of course, it says don't forget plus c. And then really I'm going to add on a step 7 here. And the step 7 should be check. Let me just write the words. Check your answer. Okay, so that's really what I like to do is after step 6, I check your answer. So I'm going to scribble off this number right here. In fact, I'll scribble off a bunch of those numbers so you can see what it was compared to the last page. And I just want you to remember, don't forget plus c. If you forget plus c, I actually do have to take off credit. I know it's crazy, but remember there are an infinite number of answers when we do indefinite integration. So if you forget that plus c, you've only shown me one of an infinite number of answers, so I have to take off credit.